get that rag out of the way? White rag.
Yeah, that'd be good.
You notice the cup he's got in the bench? We just noticed the cup on the...
Okay.
Yeah, maybe I better take it.
How you doing?
Oh, you know it. Put your clothes on. Like that.
Yeah, just put it down there where you had it. Okay, and now just reach in and do your thing. And don't take that out, put it back in again. Okay, go. Ready? That's great. And now I'll go put the camera back. Okay, go. Okay, just I would say just act like you're pushing that button.
Now we're starting with a fresh piece. Document this one. Probably right there. Probably stepping on it. Better?
Right there. Okay. All right, let me pick the piece up again and then start talking about it like that.
Okay.
All right, good.
Go ahead. All right, let's document this piece that we're working on. And it looks like 746. 746 again. Let's write that down. Every fifth part we do a full documentation on the part. The ones in between, plus or minus 3, we do every fifth part.
say that again now. Tell him.
Everything that is plus or minus 3 or less, we document every part.
To get your shirt and make a noise. Better sound now?
Yeah,
Count 10 again.
it's probably this necklace rubbing. I think it's got.
May not be you, maybe the bad.
Take 3. A little behind here, guys. Got to get that cosmoline off of them. All right. Every 5th part, we do a full documentation on the part. The ones in between, anything less than 3 thousandths, we document every part. About 25 seconds. We have this thing deburn itself even. It's just pretty nice. Right, on this part we're going to have to do the full documentation on it. Check both ends, complete. It's fine. Fine.
You're done. Tell me what you just did.
On each?
Yeah, on each part. What did you just do checking that part?
I checked the threads. I checked the threads. I checked the through hole. Checked the length of the turn, diameter, overall length. That's it.
What'd you learn? Tell me what you learned from doing all that.
That the part is almost right on nominal, completely all the way through. We're running just about 3/1000ths big on the oil through hole. It's fine. We got plus or minus 10 on it. Yeah, that's fine.
Real hole tolerance, that's pretty good anyway.
Yeah.
Okay. Good. Hold on, let me roll. Okay, tell me your name and how to spell it.
Okay.
Where you're from, where you live.
Ray Stufflebeam. Stufflebeam. Work at Hill Manufacturing. Live in Broken Arrow, Oklahoma.
How long have you been doing this?
Been running machines and equipment for 28 years.
How'd you get started in this? How did you get started in this career?
Back when the oil crunch came the first time. Yeah.
Was it a good change from getting out of the oil industry into this?
It was kind of scary at first, you know, because I didn't know what I was doing. But OSU, matter of fact, helped me get where I needed to be.
How did they help you get where you needed to be?
I took some of their training courses, running CNC equipment.
Was that down at Okmulgee?
Yeah, and different places.
Right. So now you've been at this how many years?
28 years.
So what do you think of it as a career? You enjoyed it, and if so, why?
It's fun. You learn something every day. And if you don't, you need to get out of the business.
So what would you tell a young person thinking about this as a career?
It's one of the careers that'll take you as far as you need to go. And you only limit yourself.
Good. Thank you.
Yeah.
Anytime we can pull down the car, close down on the runner, do a inspection test. I've got three or two, one SO30 Hostley, I've got Thomas Holloway, and I've got Puma, Bailey 200. Oh, they're nice. Really is peaches. I've got wow.
Yeah, that's awesome right there.
It's all got it too. Hey, Josh. Man, I'm glad to see you didn't get laid off, bud.
You can walk on in and talk to him.
He barely slid through it, but he made it.
That's good. That's good, man.
One of the two, yeah.
I was wondering if I did those quick doors. I was afraid you got it. So it's just you keep the bowl with me.
But we're almost up there. Like 70 people.
I talked to Fred Miles over the Great Winter when I was working. I guess you guys want to work on the book here. You want to go. I talked to Fred. He said they had over 52 weeks delivery to the customers. And they went from that.
And you just kind of like pretend you're talking to a group of students. I don't know what you're doing.
I'm going to move this down here for now, okay?
All right. I am rolling.
Okay. I'm gonna blow out the jaws. Make sure there ain't no chips in the way. Make sure the part's clean. And press go.
So just tell me now, how long have you been doing this?
I have been doing this for right at 8 years, 8.5 years.
So I guess that's not how you really like this.
Yeah, it depending on what you get into, like a chop shop like this, where you know you're always doing something different. It's exciting, you know, as opposed to working in a place where you're doing the same thing over and over. It gets kind of boring to me. So.
This isn't like that.
The what?
This isn't like that.
No, because you're running something different every day. You know, it ain't the same part, so.
And how do you, what would you tell a young person thinking, would this be a good career for me? How would you tell a young person this would be a good career for me?
The pay's good. You can have really good benefits. And it's something that there's always going to be a demand for.
And what kind of lifestyle is it opened up for you?
Well, I drive new vehicles and, you know, everything goes pretty good.
Is that done now?
This is done.
Well, kind of walk us through what you're doing now that it's done.
Pull the part out. Blow it off. Blow the jaws out. Put it back in. This is a flip-op program, so we run one side, turn the part around, run the other side. A little over a 2-minute cycle time. Well, I applied for a job down in southeast Oklahoma at a place called Franklin Electric, and they make their own products. They make submersible electric motors, and I passed high enough on my math test that they thought I'd be a good machine operator, and I just excelled at it from there. it is just about done. Last tool fixing to run. Get the chips off the drill bit. Don't never grab chips by hand. They will cut you. Pull the part out. Blow it off. Grab another part. Blow it out. Ready to run another part. We number our parts to keep them in order because we keep track of our documentation. Got to make sure there's no burrs in the part. And this is just a Deltronic pin that should slide through the part. And then write our measurement down. Every fifth part we got to document 100%. And that's all there is to this job.
Good.
This is a pretty simple little.
That's not simple. What's that bore? What kind of tolerance you holding in that bore? 2,000, 3,000?
Plus minus 3.
Plus minus 3?
Yep. And the pin is on bottom tolerance, so you know if it slides through there, it's good.
That's kind of the dimension balancing thing. It's a functional fit.
Yeah. And we have one other function gauge for the side hole, which mainly on mills, because on a mill it's easy to get off, which would be your y-axis on a mill. On a lathe, the turret would actually have to be knocked out of whack before that hole would not be in the center of that part. You know, and with live tooling, we have the benefit of eliminating another setup on a mill.
How many live station toolings does that machine have? How many stations have live toolings it have?
We actually, the way it's set up is every station you can put live tooling on. Right here's, pull this cover off, and that slides in. So we could, you know, if we had something that had a whole lot of hose drill in it, we could load it up with live tooling and do it. We have one part that we run one side of, we flip it around, we run the other side, bore it, and put all the millwork in it. Whereas where we used to have to load it on the horizontal to run them. So.
Okay, just tell me your name and how to spell it and where you're from.
My name is Charles Seeley, C-H-A-R-L-E-S, S-E-E-L-Y, and I'm from Coweta, Oklahoma.
How long have you been doing this?
Do what?
How long have you been doing this?
8 years.
Good. All right, I'm just going to take some pictures of parts.
All right.
Maybe
No.
you can measure the tolerance on that one again.
Do what?
Maybe check your part one more time. Use the intermic, something like that. Check the ID mic, something like that.
Yeah, this is a tri-mic, and check both ends of the part. Occasionally you want to check out here and down the part to make sure your tool is not tapering. Has a pin in it to make sure the hole is on center line. Fits good. I didn't deburr this one. Still ain't going.
That gauge is about the only true way to check cylindricity, to make sure it's completely round all the way through it.
Yeah,
If the hole's not bent or...
you know, if this won't go through, then whatever this fits on won't go through.
Yep. The functional gauge is the best way to check cylindricity.
Yep. So,
Just like that.
just like that.
Yep.
Every part gets checked. Every part has to be checked with the Deltronic pin, regardless. Because the last thing you need is customer without getting parts that they can't use.
Nothing worse than that.
Nothing worse than that.
Nothing worse than angry customer.
No, angry customer means you don't get work from them.
Right. That's darn right.
This is a turn ground and polish cold drawn stress proof. This part, it looks pretty simple, but it's actually got quite a few tight tolerances on it.
What's the hole size tolerance on that?
The hole size tolerance is a +or-2 with a location tolerance of +or-2. So it needs to be in the center of the part and at the correct location. Obviously the customers feel that it's a critical part. The OD has a +or-1
on it. The finish is a very tight tolerance finish, and the grooves are pretty critical in this particular part. Yeah, and then there again, the holes and the hole size and locations are quite critical. We'll take these parts out, blow them off, get our trough fixture ready for our other parts. We can't have any chips or debris or anything in there to keep our part from sitting square. We tighten them down. We don't want to hammer down on it. We don't want to get into our finish. We don't want to ding up our finish.
The customer supply that fixture? Did you guys make that?
No, we made that. We made that fixture. It's a pretty simple fixture, just a V block with a pin in the center to give you a stop on each end. Punch the button and away it goes. Then I'll come over and I've got 2 pins. The nominal size of the hole is 252, plus or minus 2. This pin is the go pin. It's a 250 pin. This is a 254 pin. We want the go pin to go, of course, and it goes. There it goes. And of course the no-go, don't go. Then we'll take our pin mic to make sure we're in the center of the part. And we want both sides to read just as close to the other side as possible. I'm getting 249 right there, 249 thou. 249 thou and about 2/10, so that's pretty close to dead center. We like that one.
Can you put that part back down? Put it back down. Can you hold the part? Oh, never mind. Go ahead and do that.
Well, with that being such a tight tolerance, we've got to check every part.
We were talking to the other guys. They were saying that anything under plus or minus 3 that you check 100%.
Correct, and I will document these. As fast as this runs, and then I've got some debar also to do, I'll probably run about, 6 of them, do my debar and documentation. As a matter of fact, I'm gonna step over here and do my debar.
What do you do to debar?
I'm gonna do it right here on this.
Well, that's working handy.
I'll do it right there. And then I've already checked these, so I'll go ahead and document.
Oh! Let me get over your shoulder and get you doing that.
And then every part I check the hole size, and every fifth part I check the location on it. And we've finished up another part.
How did you become to be a machinist?
Well, that's a funny story. I was out of work and had been for a year, and this was back in the this was back mid 90s, I guess. Well, early 90s, because I've been machining now for 13 years. But a friend of mine owned a shop and come to me and offered to teach me a trade, and that's how I got started. It was a thing that once I did it, I realized that this is what I want to do from now on. And like I said, I've been doing this for 13 years. Mills, run vertical mills, horizontal mills, lathes of all shapes and sizes. I've been here at Hill Manufacturing for 4.5, maybe 5 years.
You recommend this career for any young man?
I do, to a point. You do need a strong math background. If you struggled in high school in your math classes, you might want to consider something else. But if math was your thing, definitely. And math was always my thing when I was in high school. I loved numbers, and this is all this is, just is numbers. Numbers and number lines.
We tell our students the same thing. You have to have a strong math background or...
Yeah, or you're in trouble. Definitely. You've got to know, you may not know where you need to be in that equation, but you need to know, you need to have the skills, the math skills, to realize when you're going in the wrong direction.
Can I get a charge of you holding one of those?
How about one of these that are finished?
Good. Tell us your name, how to spell it, and where you're from.
Okay. My name is Jimmy Pollard, Pollard. I'm from Wagner, Oklahoma.
We're taking this regular office shot, so come ahead and do a look at things. Want it? No problem.
Actually, a great project for Lucy. Keeps her busy.
That's what she said. She's very good at it. You guys have business with Tony?
Yeah, I actually got some stuff here on